I'm Vukašin, I'm the founder of CloudMe, and I want to start by asking one question to everyone here. How many of you have an idea of what the cloud is? I hope many. Yeah, fair enough. The rest is probably just shy. The thing is that 50% of the people think that the cloud is affected by weather, which is scary, but in a way they are right. We can't cope with natural disasters and so on, but I don't think that was their point anyway. The point is that the cloud is hard in a way. I mean, basically, in order to answer the question, is it hard or not, we have to go back what the cloud is. And the cloud is basically the way we called something that we I mean, the cloud is what you see on the right. On the left are just normal machines, basically just computers. But some time ago, sometime before I was born actually, we had a problem that we had big machines and we needed to find a way to split them into smaller pieces. And in order to do that, we needed to invent something that we today call virtual machines. And basically that's this transaction from physical to software, from physical to something that is not actually real, it's just code. And it can be also managed by code. That's the point. We don't have anymore to call system admins just for deploying one machine, which can take even weeks. While deploying one virtual machine, it's probably minutes today. It's less than a minute. DigitalOcean is doing that in 55 seconds. Now, okay, so we went from days to minutes, but we can do even better. But let's get back a little to what's going on right now in the data center. Basically, you can see those virtual machines, and for some time, one virtual machine was fine, and that's why, in general, we did that. That's why we created those virtual machines, so that it fit better for everyone else, for as many people as we could, because one physical machine was really expensive, and it was not easy to give to someone to use because it would cost thousands of dollars. But with time, especially when the internet grew, we couldn't really use just one virtual machine. Or better, we couldn't use a virtual machine of this size. And those are just fixed sizes. So basically, it's just 1/12, I don't know, of the physical machine. Then what we did, we took bigger machines, and then even bigger and bigger until we hit the wall. Where we couldn't actually have bigger machines than the machine it was running on. And that's when we thought of clustering. That's when we thought of combining multiple machines in order to solve a specific problem. And right now in the data center, we have this situation. We have some machines that are labeled just for certain jobs. For example, in this case, it could be Hadoop. We have a Hadoop cluster. And on another 10 machines, we have a web server. But we labeled those machines just for that, nothing else. And that's fine in a way. I mean, if we want to scale, we can scale. That's not a problem. But again, let's think what we are doing here. Basically, we are taking physical machines, we are splitting them in smaller pieces. We are losing performance, by the way, by doing that. And then we are going back and we are merging those machines into one a little bigger machines. Maybe it's a different size, and maybe it's fine-grained in a way, because again, those virtual machines are fixed. But it doesn't make sense. I mean, it does, but it doesn't. And everyone will take that as its own. But the point is that we can rethink the data center a little. Why do we try to make many virtual machines instead of trying to make one machine? Isn't it natural to use one machine? I mean, we're all using one machine at home. My laptop is one laptop, it's not 2 or 3. And it's natural for us as engineers to use one machine. So let's try to make those machines look like one machine for us. And in order to do that, first of all, we have to rethink what the virtual machines really allowed us to do. And in order to do that, we need to get back to the virtual machine again. So we have the bare metal on the bottom. Basically, that's the physical machine as my computer would be. Then the OS, in my case, it's OS X. It could be Linux or so on. Then we have a hypervisor that is managing other operating system on top. look at that guest OS. I mean, in a way, it doesn't have a sense, but it did at that time, because we wanted to make that transaction from physical machines to virtual machines as easy as possible. So a programmer at that time wouldn't need to learn to use programs in another way. We just made virtual machines, and he used that virtual machine as it was a physical machine. No different. Now, we have something today. Actually, we had that for quite some time, about 10 years now, which is called containers. Basically, Linux containers allow us to isolate resources as we would do on virtual machines. But they're not so nice. That's the problem. And you have quite a few companies using containers, basically decades. Google is shipping every day about 2 billion containers. It's not something new. It's something that really exists, but it's not that easy to use today. Now, what happened in the last few years while the container boom exploded is that Docker came in. Docker really didn't want the containers to be just for those big companies or for people that really knew what Linux was in all its parts. They wanted Docker to be something that everyone could use. And they did so. They did so by making, first of all, a nice CLI and really making them manageable. Then they did by making a repository where you could push those containers and pull again, and basically not depend on anything more than an internet connection when you want to deploy stuff. Now, how a container looks like, basically we don't have anymore the guest OS. We have something called the Docker engine, and Docker engine is really fast, and it really allows us to be flexible, and it does really improve performance as well. Now, as you can see, every application has its libraries, and every application in that container does not depend on anything else. So that's the point. We have those applications just working. And when we do that, we can just push them around as much as we want. And for example, my computer is rebooted today. I have no libraries. I have nothing. I had to think about those things. I have to think what I have on the machine. Will I be able to do the demo because my machine crashed yesterday? And I had to reinstall everything, and I'm sure I forgot something. And we'll probably see that. But the point is that we can also scale. We can also scale because there are so things that we can push them as much as we want. And we don't need to push them on one machine. We can choose on which machine we are going to be pushing them. Again, because of the size, they are really portable. It's really easy to just transport them everywhere because they're kind of small. And again, this is not only about size. It's about another concept that basically they just share the libraries between them. So you have Ubuntu, but you have just one Ubuntu. If you had Ubuntu before on that machine, you won't be downloading Ubuntu again. And when I say Ubuntu, I don't mean the whole Ubuntu, but just the kernel and the stuff that it's needed. The stuff that is needed to run an app. Again, deployment is really easy. You just push a container, and that is gonna change many things because everyone is gonna be using them because it's easier. I mean, you don't have to deploy machines. You don't have to SSH. You don't have to use any of that. You just push a container on a cluster. And again, by doing that and by having so many small containers, we are able to increase the density of the resources that we are using. But the best thing is that it allows us to really push microservices. And microservices are the biggest thing here because they are going to allow us to split the focus from the developers on different things. And you want it or not, you can't have teams bigger than 20, 30 people and be efficient. It can work, but it's really efficient if you have from 6 to 10 people. And if we can split the tasks even smaller, we are going to really push, in general, the society in a way. I mean, it's really going to change the society. This is not something small. It's going to change the way we work on stuff. And we all work on projects here. So now, Kubernetes. Kubernetes is, first of all, it's a project from Google, and they've been working for some time on that. Before that, they had Borg, and Borg was basically their private implementation of Ubuntu, of Kubernetes, similar to Kubernetes, but the point is that they didn't really want everyone else to be using it. But when they saw Docker, and when they said that something was going on there, they felt the responsibility to do something about that. I'm sure they had some internal project back then, and they made Kubernetes open source. So Kubernetes is absolutely free, and many companies are working on that, including Red Hat with the OpenShift team, and again, OpenShift is using Kubernetes as well. But what is Kubernetes? Kubernetes is the thing that allows us to watch that cluster as one single machine. And it does so by making some abstractions. And the first abstraction is the pod. Basically, a pod usually is just one container, but it doesn't have to be. The pod really is the smallest unit of scheduling that we can do. And when we want things to land on the same machine and also use the same resources, we put them in a pod. And the simplest use case is WordPress. For example, we want WordPress to go together with the MySQL database, and we are going to put a MySQL container in that pod. And they are going to go everywhere together. We are not going to come in a situation where we have one container on one node of the cluster and the other on another one. But again, maybe WordPress is not the best case, because we can also put the database on another container and connect to that, because we want maybe that container to be bigger. But if we have something fetching stuff from the web, and for example, Nginx serving that, there is no point in having them on separate nodes, for sure. Now, again, they share resources, but they share also network, they share RAM, and basically they're on local host, so you can access them just through ports and so on. Labels. Labels are really important, because labels allows you to really ask the cluster. For example, I want to know what are the nodes. I want to know the pods that are front-end and that are in production. I need to do that by putting labels on them. And Kubernetes is going to answer me that. Now, we have also services. Services is basically allowing us to have those pods and be able to access them through the web or from external sources. But the most important thing to understand about Kubernetes is reconciliation. And this term comes a little from robotics. In general, it's trying to stabilize things, trying to make things balanced in a way. So let me explain that. For example, we have the current state, which is full and bar, and we want just to be full. And what reconciliation is going to do is going to keep that pod full all the time. We don't say Kubernetes launch me that or launch me that else, because if we do that, then we become the scheduler, not Kubernetes. While doing this, we can go home and sleep. He's going to manage everything. He's going to care about how many pods are running and if they are running. So we can add, again, the same concept. But the thing is, by using the same concept, what Google did on the Kubernetes project is focus on one piece of code. Focus on just reconciliation, nothing else. Because that's everything that's going again and again. Health check as well. Health check is still reconciliation. I'm just checking if the state, if the current state is the state that I had before. And also replication. Now, what is replication? Replication is basically telling Kubernetes, I don't want just this pod. I want 3 of those pods to be alive all the time. And if one is going to go down, he's going to fire up again another one, which is amazing. I mean, that's not that easy with virtual machines. I mean, kind of impossible to do in such a short amount of time with virtual machines. And that's what we can do, every one of us, for free. It's an open source project, and many people are working on that. And by being open source, again, it's growing really fast, and it's growing the direction you should be going, because it's not just one company dictating the future of the project, it's all of us. Now, let me fire up some pods. And I'm gonna do that, hopefully, because I fired up the cluster this morning, but knowing Google, it's working. So I know that you can see right now. Is that fine? Now, now first let me check if it's allowed. Get noise. Yeah, cool. For some reason, I have 2 nodes that are not responding, but again, because of the nature of Kubernetes, I don't care. I mean, I have 2 nodes working, and Kubernetes is managing where it's going to shell that. If it's not ready, it's not going to shell on that node, and that's it. Now, in this directory, I have actually basically, those are bash scripts. If I want to access the API, I'm just going to send something like this. Create. So basically, this is the address of the master, and I'm going to send that master a description of the pod that I want to run. And we can see that description. Basically, it's saying just what containers to use and where to pull them from. So I have the pods. It's something like this. Again, you can see how easy it is. I mean, it's just a JSON file with just the specification. If you follow the syntax, is going to be really easy for you. Now, let's try to run a pod through that API then. And this is the pod, and it's working. Now, most likely, now you can see that the status is pending right now. And we're going to see that with get pods. And it's running. It's already running it. And the age is less than 15 seconds. So you see how fast this is. And in order to access this Nginx container, or better, pod with a container inside, we need a service, as we said before, in order to be able to access them from the external world. And we are gonna create a service just by running this script. But again, it's not a script, it's just one command. And all of this that I'm doing, it's also done by the CLI, which we are going to use in a second. Now, let's create this service, and let's try to again. We have the service running on this port. So let's try to access that service, and we get the Nginx initial page. But let's do that from the browser. So what I'm going to do is kube master. I'm going to copy this, and I'm going to go there, but that's not enough. I just need to know where I have the double. Okay, just give me a second, please. Anyway, I'll get back to that in a second. Let's then see what we can do with uh, the kubectl, which is basically the default way you're going to access your cluster anyway, other than having web services control that and so on. So now we want to so we get the pod and we want delete, and the pod name is nginx. So it's not just nginx. Yeah, again, let's use the scripts and we destroy this pod, and we can see that by just fetching. And again, let's destroy the service, and we can see both of that way. Okay, that's it basically. Now we have another 10 minutes if you want to post questions here. Yeah, I'm fine, I guess, because I mean any question in general. I mean, containers are a big thing right now, and not only right now, in the future are going to be as well, because they basically change the way we look at resources now. I mean, virtual machines were fine until some time ago, and they were fine the last 20 years. But I think it's time to change it. And I'm not the only one of that opinion. Please, do we have a mic or? Actually, this is running on Mesos. No, the thing is that Mesos is just a resource scheduler, while Kubernetes is orchestration for containers. I mean, you can use both of them. For example, right now, all of this is running on Mesos, and on top of Mesos, we have the Kubernetes cluster. And it's much easier to add nodes and so on. But the point is that as well as running Kubernetes, you can run Hadoop, you can run Spark, and whatever. I mean, Mesos is not natural for containers. It's just for deploying that. But they don't use the concept of reconciliation as Google wants to. Again, you have Swarm. Swarm is an orchestration as well for containers. Yeah. It's huge. I mean, pods are basically just what contains those containers, what really merges those containers, whilst the services basically allows us to access those containers. And I mean, it's really hard to access something that is going around the cluster, jumping from one node to the other, because those machines are going to have real IP addresses. So we need to, in a way, fake IP addresses and fake IP tables in order for us to be able to access them in an easier way. And that's what services really allows us to do. Now, other than, I mean, okay. Ansible is just for, I mean, it's just for deployment. While Kubernetes is the thing that keeps your cluster of a certain state. It's what keeps the state that you want it to be, while Ansible is pretty much for deployment. And yeah, it does fit, because you could be running Kubernetes on bare metal, and it's much easier for you if you use Ansible to deploy a node than that. Okay. I'm here if you're wondering anything about containers, Docker, and the DevOps world in general. Thank you.